of these systems were built using the same underlying architecture. And that's that they were using what's called a pipeline architecture that uses text native components that were not built from day one. They weren't designed for real-time voice. And in addition to that, many times SIP was an afterthought, something that they tried to bolt on in a non-user-friendly way. So we needed to understand, how do these systems work? What exactly is a pipeline system? How does it work? And how do we look at the different components so we can enhance those components to get to the level of experience that as providers we know we need to deliver? So the first thing is that we noticed that transcription-first pipelines, right? And when I say pipeline system, I'm going to show you a diagram as to what it looks like, and I'm going to explain it real quick, okay? So a pipeline system, what happens is the audio comes in and it gets transcribed. The transcription is sent over to the model. The model then interprets what's happening. The model gives you back text, and a text-to-speech vendor speaks it to you, like 11 Labs, right? And that process happens over and over and over. Well, starting with the transcription, at times the transcription can add lag, okay? It can include errors, and it can lose what we call conversational signals, okay? And on top of that, there's other little mechanical problems. Sometimes the transcription can buffer the audio to increase the accuracy, which can make it feel slower. On reducing conversational signal, you have what we call timing or prosody cues that get lost in conversation. We proceed from there, and we notice that turn taking was a little bit broken, right? So if your VAD system is not optimized, or if your VAD system, if your turn taking is heavily dependent on the transcription, we notice that that's not really optimal, right? Because the way the transcription works is that the transcription is grouped into chunks, okay? And those chunks might be a complete word, a complete, it may have punctuation in it, it may be a couple words. There's no specific pattern to the chunky. Different vendors are different. So when you're receiving conversation in chunks, you need to now measure if the person's done or not in chunks, right? So you need to wait a long time to see if you got to wait the next chunk to determine if that's ready, or you have to process the chunk, and that's where the problems start coming in. The next thing was that the systems where I could, for example, come in and pick models like ChatGPT or Claude or these things, the closed models that we know and we chat with, okay, those models run on what's called shared inference infrastructure. Okay, for the most part. And what happens is, in a shared inference infrastructure, all of the inputs, all of the requests, they're batched, okay, and they're microprocessed for efficiency. Now, in the text world, that's okay, because in the text world, if my response took, like I said, a half a second or 1 second, it doesn't matter. But in the voice world, we know the deal. 500 milliseconds is a long delay for anything in voice related. So that is a bit of a problem there, the way that the models are running and the infrastructure that they're on. And then the last thing we noticed is that some people had good knowledge systems, and some people didn't. Some people had these systems where they would say things like, you put your website URL and we crawl it and we know things about you, or you can point us to here or there. But those systems, that architecture, that style, it's a little bit too Wild West. It's not designed for AI. It doesn't help AI focus on context that matters. So the question was, okay, why was it happening? We figured it out. We needed to understand, what are we going to do from here? So now that we know most systems are used building pipeline, this is some of the consequences of a pipeline. We see vendors out there putting out solutions to try to improve pipeline. We got to get around that, right? So what are the conclusions that we reached? We had to build something a little bit better. We needed something that was speech native for real time, and it had to be practical, right? So I needed fast, natural conversation pacing, and I needed faster responses. I needed consistent performance. I couldn't risk having different experiences throughout the day or throughout different calls or in the middle of a call. I needed reliable turn taking. None of this awkward silence, none of this talking over each other, okay? I needed best-in-class knowledge with context that an agent could focus on so that it wouldn't grab unrelated information and perhaps have a hallucination. I needed flexible integrations, like I explained before. No-code, low-code, I love it. We have it, right? But the problem with no-code, low-code is not scalable, it's not maintainable. So I needed an easier way to be able to integrate faster so I can deploy faster and then maintain better as I got bigger. And then the last thing is it had to be UCaaS SIP native. I mean, just having to forward your calls to the PSTN, the voice providers on the phone, they know this deal, right? You forward to the PSTN, you forward back, that adds a lot of time, it adds a lot of cost. The PSTN can break, it's extra legs, it's inefficient. Because at the end of the day, what we understand is that your customers don't want AI. They want outcomes. And this is the environment that you need to deliver outcomes for the customer. So what does designing for outcomes look like? Okay. So here, guys, shameless plug, we are going to explain how we built our solution, FlowbotAI, okay, which is a service provider platform for delivering AI voice agents.